Okay, we are recording. This is the June 18th, 2020 Object Storage API KEP review. I'd like to start off the meeting by addressing, I guess, the first point of work. And so Sid and Srini and myself have been working over the week to start to address different points and fields and bits of data that we're going to need to start putting together a gRPC interface, which is at this point kind of a blocker for obviously developing controllers, but also developing a CSI volume driver. And we've decided to focus our efforts first on the make bucket RPC. And as part of that, so having done a little bit of research on what's required across the cloud platforms, a couple of questions have come up. The first is that how granular should the control be for users creating a bucket up front? Or to restate that, should we just give them a bucket and the keys to set policies on that bucket, or should we allow them to request, for instance, a canned ACL to be created on that bucket up front? We haven't really come to a consensus on that yet. So that's the first question we'd like to put to the SIG in terms of getting down into the nitty gritty of this.
Hey, John, do you have like a set of notes here following that we should be looking at, maybe?
Oh, no, I don't, not in this case, but I can.
Okay.
So let me kind of share the, where is it? Here we go. We do have a working sheet here for each of the major cloud providers, which kind of wraps up S3 being part of it. So for instance, when defining a bucket, from the, and I imagine this would be in the bucket class, but there are certain fields that go into a create call that we would give to, you know, as a driver, you'd be either through an SDK or through HTTPS, just RESTful interface. You would pass at least these fields for S3, for instance. GCS has their own set that don't differ too wildly, and Azure is similar. In the case of S3, there's a distinction between ACLs and what are more of like a identity like permissions list. Now, the identity permissions list portion of this is being deprecated in AWS. ACLs, on the other hand, are still a feature of buckets, and they control more of a public access or anonymous access, such as, you know, public read, public read write, public get, that kind of thing. And
I'm sorry, you're suggesting that IAM policy?
No, so I'm
advocating in favor of IAM, but then what I heard you just say is they're not doing IAM; they're just doing gross.
Right. Yeah. So this is a confusing distinction with AWS that I've had to reread the docs on it a few times. They have 3 separate subsystems for controlling access. The simplest one is an ACL by their definition, and that is simply the anonymous access, right? So the bucket is either private, no one can know, it's not publicly available. It's public read, or it's public read write, or it's authenticated read. These are very general. They don't define identities. They just say, you know, if you have network access to this bucket, this is the permission, the canned permission that you get. It requires no credentialed access, no identity. The second system that they are using now is in the IAM side, where an IAM role is specifically given access to a specific storage instance under a set of permissions. And that's the current in-use role. The third role, or the third system, which is deprecated, is housed within the storage side, right? So the IAM side is the identity management with the roles and identifies the resources that role can access. The deprecated version is written onto the bucket metadata and defines the identities that can access this resource. So it's kind of the inverse.
I think that sounds exactly like what Google has.
Okay.
and it's the same deprecation.
Right, right. And Azure has something similar too. The only difference that I've seen thus far is that AWS specifically is discouraging people from using that system of writing to the resource metadata, which identities can access it. So one question that's up in the air is, more broadly, should policy creation on the storage side, when I'm creating my storage instance, be part of bucket creation? At the very least, should we allow users to set a canned ACL on that bucket, being this one here?
Yeah, my gut is that is expressible through IAM, and the notion of provisioning public buckets as part of this whole system doesn't seem to make a lot of sense to me. So I'm not sure why.
Public buckets to that cloud, or public buckets that could be accessed through different namespaces in Kubernetes? What do you
Well,
feel?
the impression that I got was this was a global sort of anonymous access. So that's effectively defining public access to these buckets, right? That's what the canned ACL is really addressing.
Yes.
Yeah, which
if you have the URL, you can.
I would say, I guess, that is something that maybe should be handled just with bucket class parameters or something that's specific to the particular storage system. I don't see why that would be a first class thing necessarily.
I agree with that. I think it should be an opaque parameter as part of the bucket class, just like we specify different attributes of the cloud within the storage class, like zone or IOPS, things that can change depending on what you're using. I guess when you say first class citizen, that implies required, right?
When I say first class, I mean that we directly model it, and so it's seen as an important part of the implementation, as opposed to something that we allow you to do, but isn't necessarily applicable to all of the backends.
Right.
Okay, so why did this come up, I guess, John, in your conversation on Monday? Like what was the use case around having this be like a critical piece of the API? Can you elaborate on that?
Yeah. So there's maybe a couple of different philosophies around this. One, the one that was driving me initially was exposed to the Kubernetes, not necessarily through the user-facing API, but at least through a bucket class, as many configurable things as that cloud platform offers. If I can, at the point of creation for a bucket, specify these things, then it seems like that's something we should also expose at the Kubernetes layer, instead of stripping out some of the APIs. Now, on the other hand, another philosophy is, well, bare minimum, we just create the bucket for them. The user has access to the bucket, and if we've made them the owner because it's a new bucket, they have the rights to, modify the ACLs after the fact, or object policies, etc. So why would we do that? Why would we make that a as Andrew put it, first class field in the API?
I think there's a difference between first class and having it as a configurable parameter in bucket class.
Mm-hmm. True.
So, I mean, the other thing that came up that made us want to think about this was, should we have an anonymous access field in the bucket class? That was kind of the question. Rather than having like make private bucket as a separate API.
I guess my point is, the whole thing that we're trying to do here is to provide an infrastructure for dynamically acting on bucket requests by applications. the whole use case that implies this seems to be a use case that you would just directly provision your own buckets. I mean, if you're going to do public access buckets, I mean, that's not something that you would expect to have dynamic behavior on when an app comes and is installed in a Kubernetes cluster, right? It just seems like it doesn't, that would be more, it looks to me like more of a brownfield case if you were going to use that bucket. Does that make sense?
It does. I could think of one use case. Sorry, go ahead.
Sorry, so I was going to ask, so in the terms of brownfield, are you imagining then that this would update the ACL on that bucket? Or
no, I'm suggesting okay, so if you decide you want these ACLs as a fundamental property of the bucket and not as a property of the interaction between a particular subject and the bucket, right? Then that would make sense to be something that is involved in the creation of the bucket. But all I'm suggesting is if you're creating buckets for which there is any kind of ACL other than private, then it strikes me that is really something that you should be doing out of band, and then just accessing that bucket. Then you provide separate IAM, and maybe those if it's a public read, then maybe we need a path where you can say basically just rely on the existing ACLs that are in the bucket and don't add any extra IAM for me. All right, so I could understand having to be able to support that path. It just seems weird to support the setting of global permissions on the bucket, other than through kind of an opaque parameter to the extent that you want to do that. I just still think that's just weird to dynamically provision public global parameters like of access.
Yeah, I see your point on that.
Yeah, but shouldn't it be, I mean, I get it, but at the same time, don't we want it to be consistent? How we provision, like, should be the same usability path, then suddenly different just because of the ACL setting? I don't know.
It comes from the difference between the location of the provider, right? So if you're taking a cloud service, which is external to the cluster, then clearly creating like a public bucket for an application is not really considered anything. But if you take a provider inside the cluster, then suddenly public just means that it's not providing any IAM limitations inside the cluster first, and then the networking in the cluster is the one really creating. So perhaps you want to have like a bucket for your testing inside the cluster, right? Something like that, or anything public in the sense of inside my cluster. So I think this might be where the difference comes from, where for Google Cloud, it's probably less relevant, right? But for providers inside the cluster, you get what I'm.
Yeah, you're saying in on-prem instances or on-prem setups of object storage services, public would mean something entirely different from what it means in public cloud.
Yes, right. In cluster, I think the model, not on-prem specifically, but yeah.
Right.
Yeah. Let me see if I can't play back an interpretation of what you just said and see if it rings with you. What you're suggesting is, I think there might be two entirely different approaches for access management to buckets. One of which is that for every access, I'm going to express some sort of subject-specific permissioning. But I also want to support as a first-class capability the ability to not have to specify those kinds of things and to just make them aware of the bucket and then they can use it. And in order for that latter one to be a fully supported path, that means I've got to be able to support it even at the bucket provision level.
Yeah, I mean, I don't know if it's so, yes, but just the last piece is I think I didn't say what I think would be the right solution. I don't know. It might be that
No,
it's really...
I'm trying to get my head around this because I'm
Yes.
not disagreeing either. It strikes me that that means that there are two models rather than one. And I don't disagree with the validity maybe of the second model, particularly with respect to things that are where public doesn't really necessarily mean public. It means public to something that,
Like
as
my
far as
internal
you know,
network, for example, my pod network, let's say,
yeah.
or subset of it by network rules, etc.
Now the question is, do we want to take an opinion and have only one approach?
So by not standardizing, we're taking an opinion as well, right? But if we standardize some thing which is required, we are essentially creating like maybe we are forcing somebody to implement something irrelevant, and so it might be an optional. So it can be standard in the sense that it does. You can specify what that this thing might exist, but it doesn't have to be implemented.
So let's call one of them global ACLs and the other more fine-grained authentication and authorization.
In the bucket class, is that the scope?
Well, I think that the two-layer model suggests that, and this is why it bleeds over a little bit, because normally we wouldn't think of putting any kind of permissioning at bucket creation time, right? We were doing all of that at the bucket access definitions. And so this is positing a model where the bucket access definition doesn't actually have permissioning. It says just rely on the underlying permissioning and move that permissioning to the bucket. I don't think personally that ought to be the only thing we support, but if it is an allowed model that we support, I mean, I guess I can see some of the rationale for doing that, but I think it's a little bit tricky to express the fact that there are both of these models, and how do you how do you option that? How do you make parts of that optional, and how do you configure, and but it's possible.
Yeah. I mean, in the case of, so making the distinction in the API, with the bucket access versus the bucket request, when it comes to public read, public write, like that absents out all of the IAM operations by default, right? So
Right. That's what I'm saying. So the question would be, which thing do you think ends up providing you the info on the bucket? And so we were talking at some point about possibly having the bucket access be the thing that does that, and then it references a bucket. So that would mean you would need a bucket access even if you had no permissions, which implies you would need a permission on the bucket access that effectively says rely on the underlying bucket access, right? Don't provision any for this guy. Just rely on what's already there, which might have usefulness, oh, by the way, in another way, because it might be that somebody has already provisioned those IAM permissions outside. And so you want to provide the Kubernetes level visibility into this without actually taking action on provisioning IAM rules. So I actually think it might be useful to be able to say at that bucket access level, essentially, here's the bucket, assume this guy is already independently allowed to talk to it. And then
identified.
Yeah. And then that, if you support that, there's reasons to support that, I think, even if you didn't support ACLs at the bucket level. But it just turns out
it actually merges pretty nicely between these two things, right? Right. So public access is also an implicit access, right?
Yeah, exactly. From the access point of view, as opposed to the bucket provisioning side. Yeah.
Right. John, by the way, do you have you had a very like the last diagram we had for all these entities? You have it on your slides you can share?
Yeah, let me pull it up real quick. Yeah, and just another good point, that it's something we haven't quite, at least I haven't understood that we fleshed out yet, and that is, what are the responsibilities of the bucket request and the bucket access in terms of representing that data to the user side, right? Because in my mind, at least, I thought that the bucket request would be responsible for transmitting connection information, and the bucket access just credential information, rather than wrapping them both into the bucket access. Now, I don't know if I'm just on the wrong page from everybody else on that or not. But is that how you had kind of envisioned it?
I'm sorry, could you repeat that last bit?
Also, it will be helpful, John, if you can pull it up.
Yeah,
I think it would
yeah,
be, like looking at it would
here we go.
would keep us focused on where we were. Yeah.
Okay, here we go. Is that clear for everybody?
You can zoom a little bit, maybe.
All right, let's bring it a bit. Yeah, so the way I had been envisioning this up until now was that the bucket request for both brownfield and greenfield was responsible for transmitting connection information, URL, bucket name, etc., back to the pod, and that the bucket access request was only responsible for transmitting if there was credentials. Otherwise, it would result in through the COSA controller an annotation on the service account to associate it, through the like a workload identifier or identity or whatever to the cloud provider. Now,
so the weird thing about this to me is writing into the secret. Then, how do you get your access credentials written into the secret? Are you suggesting two different things can create the secret and write into them? You see what I'm saying?
yeah, I do see what you're saying. And so there has to be an agreement, one, on the secret name, whether or not it exists, etc.
Yeah,
Who's updating the secret?
That's why I was assuming that one of these two would kind of be the one responsible for it and would reference the other. So logically,
Gotcha, yeah.
I think this is the model, but I was really thinking in terms of the responsibility and ownership and life cycle.
Now, a different track. So if we get the CSI ephemeral volume driver working such that we can just inject a file into the pod, maybe Sid can answer this. Can we effectively skip the portion where we need like a secret API to begin with, and we can just harvest the data from the bucket request and the bucket access, and then inject that into a file in the pod through the CSI driver?
If the credentials are available in the bucket request, yes.
Okay, so right, because we'd have to dereference this all the way back to the provisioner namespace, and I don't think that the CSI driver is probably or should be capable of that. Probably.
So is bucket a namespace resource? That it is, right?
No, this would be cluster scoped. Similar, you can think of it like a persistent volume.
Okay.
And so Andrew, just the way you're describing it, and yeah, I agree, it does make more sense.
Doesn't PV, for example, it does hold any secrets inside?
PVs do not, no.
So what do they rely for secrets?
Just to be clear, they do hold information that we don't want exposed to people with only namespace level access. But it's not credentials necessarily.
Right.
Sensitive but not secret.
Okay.
Okay, so Andrew, it would look more like this then, right, where the bucket access requests or references the bucket request.
Yeah, that's kind of how I imagined it. And then the bucket access request, might end up itself be the CSI driver thing or something like that, right? So I'm not being too anal about, it's got to exactly look like this. I'm just saying you've got one affordance from the perspective of the of the workload that keeps the workload from starting until it's available and everything else. And so that one thing can say, okay, I'm using this bucket, and that I'm using this bucket can be something that, you know, obviously either is a brownfield or greenfield, can be an existing bucket, could cause provisioning of a bucket. But it also then has its own life cycle, so that it has its own sort of, I need to take care of my provisioning operations, et cetera, for the IAM things. And so, you know, you would express at that point, I think, you know, here's the bucket I'm using, and here's the kinds of permissions that I'm looking for, and the permissions could be that pass through or whatever.
Right. That, and I think that that's a more rational approach. It also simplifies workflows between greenfield, brownfield, and the going back to the ACLs case, in that maybe I don't need access because it's just public access within the cluster, but the workflow is still the same. I still have to create a bucket request. I still have to create a bucket access request with the appropriate reference, and then that should still result in the same form of access with connection. And in this case, it would just lack credentials, which would be fine.
Right.
So,
we already wanted to handle the case of lacking credentials in the case of the workload identity style thing anyway. So
exactly. Yeah. That is a more rational design, I think. Does anyone else have any input on that?
Can you walk me through the workflow again? So you create a bucket request, you get a bucket, and then you create a bucket access request, or how does that work?
You would, well, I would hope that we can design this, and I think we can, such that you can create one before the other. There shouldn't be a sequential mandate on that. And given that it'll be handled by separate controllers, that should be pretty doable. The idea being that, okay, so for Greenfield, I would create a bucket request and a bucket access request. Now I know the name of my bucket request because I've probably defined the name static, or if I've defined the name statically, I know it. I would create my bucket request. The central cozy controller would detect this in my namespace and create a bucket cluster scoped object. A provisioner would detect the bucket cluster scoped object, which is a composition of bucket class fields and the bucket requests. And the driver side of that provisioner would then create a bucket in the cloud provider. It would write back data to the bucket connection information primarily. And that would be, and then we don't have a binding because we're following the kind of many to one bucket request to bucket, but we would have to signal to the bucket request that the either provisioning is complete, or if it were brownfield, that the connection is available. Once that's done, a bucket access request with reference to this bucket request would specify either the service account in my namespace if I'm trying to use the Kubernetes service account to cloud provider integration that all or most of the cloud providers provide, or it would specify a secret, I would think by name, that does not yet exist. So it'd be like a desired name for, you know, the secret. And the IAM side of this, so back in the central controller would detect this, would create a bucket access object that would result in either a new IAM identity or role, or it would perform the association to the cloud provider. Go ahead.
Oh, I was just finishing a sentence saying service account.
Yeah. So either it associates the service accounts, or it creates an identity with credentials. One of the more or less elegant parts of this is that because the provisioner doesn't have purview across the cluster, it has to store that credential somewhere so it can be passed back to the user. So it has to write an access secret within its own namespace, which the central controller not depicted will then clone to the user's namespace. Assuming though, that we're using secrets here, if the CSI driver can help us maybe cut out one of these steps, then that would be pretty beneficial in terms of elegance anyway.
Also, I think, correct me if I'm wrong, but this also would allow for a different cardinality, right? You wouldn't have to have a one-to-one between bucket access request and bucket request. You could have one bucket request in the namespace and have several different workloads have their own access requests for that bucket, right? Because those different workloads might run under different service accounts. They might have separate access, but you can only have to do one bucket request in the namespace to make the bucket request available.
Right, exactly.
So I just didn't want to give the impression that you have to do both of those for every workload.
Mm-hmm.
What you would do for every workload would be the bucket access request. What you would do for every namespace would be the bucket request, potentially. You can also have multiple bucket requests in the namespace if you wanted to do it per workload.
Yeah, and that has a nice parity with how it's done at the cloud provider layer anyway. So hopefully that's kind of an intuitive workflow.
So John,
yeah.
So John, here for public, for what we discussed. So since for public, we are sort of, how did we say, implicit access, right? We're sort of saying that there will not be a bucket access request at all, right? But then it still needs connection information. So just to understand, when you disconnected the bucket request from the access secret, does that mean anything in that sense?
It means that you still need the bucket access request. It's just that in this case, you're not getting anything provisioned for you on the cloud provider side. It's just providing a URL, some sort of endpoint information for the bucket. Yeah. Which is, that's effectively a similar workflow were you to use a bucket access request for a service account, because in that case, you're also not writing credentials to a secret. Now, the secret part is still, this is a bit TBD, dependent on the CSI driver.
So I will also point out, and I've mentioned it before, but I have some concerns about the fan out cardinality between bucket request and bucket. I feel like that's something that's going to bite us, but maybe not. But it just feels like that binding stuff is kind of there for a reason, and so I just get worried about, like you mentioned, like if you're provisioning a bucket in response to a bucket request, I guess if you're doing the provision, that's pretty straightforward if it's greenfield. But if it's multiple brownfields, it just becomes, I guess you're operating on the bucket request, so your status and everything is just bucket request. Maybe it's okay. Just is a little scary to me. I'll just admit that.
Is the issue reference counting?
Well, that's just it. I'm not sure if we need reference counting, because if we really split it up between greenfield and brownfield, and that greenfield is kind of one-to-one, and or that, I guess that, there you go. The greenfield case is what scares me a little bit, because if we let the greenfield turn into brownfield, if you end up, or you have multiple references to greenfield, how do you know how to clean up? Right?
I get what you're saying. It's like, if you create it here, you manage the life cycle here, and you don't want it to be orphaned out in the wild outside of the controls. So having the count there allows you to be proper about its cleanup. Is that what you're concerned about? Is like, I created here, I dereference it from every application, but that bucket exists somewhere out there in the wild, and bad things can happen to it.
I almost think the reference count isn't enough. I almost think that we actually need to have a multiple binding situations, so that I've actually got to record in the bucket all of the brownfield references to me and all of the greenfield references to me. And so that that I handle, that then maybe I only allow cleanup from a green field or something like that. I don't know.
So I think if I can translate just something, maybe you said it, maybe not, that it seems like you said you're more worried about greenfield turning to brownfield, and I think you meant maybe because of the ownership that this like greenfield allocation has over the bucket, so it also is assumed to be deleted when that application is deleted or something, or changed state, right?
Yeah,
But
like
for
retention policy.
many, yeah. So just to complete that, but on typical brownfield, you don't take ownership. You never delete. You always retain or whatever, right? That it means like you just import a bucket to use and not really control it. And you are worried because we're letting applications control the bucket, but it's not clear that we define that if I sort of am the owner and I'm deleting it, the other applications will have stale references versus another opportunity, which it might be like if I delete I transfer it, like it's just a floating ref count until the data can be expired. So there's like models to that as well. I guess I'm not sure which one would be really more relevant, but I agree with you that we don't know because we didn't like completed the life cycle inside based on this on these use cases at all. But we sort
So
of
quick
have like a
question.
flexible. Yeah, go ahead. I'm done.
My question is, so let's say we have some sort of retention policy while creating the bucket saying, delete this once the job ends. So the same controller that was responsible for creating the bucket would just go clean it up. Is that the idea? So is that going to be a sort of automatic deletion after the workload ends somehow?
Right. So that's a different question, which is whether or not the bucket request is deleted. My question is actually, if a bucket request is deleted, do I delete the bucket? If I delete the bucket, what do I do about dangling bucket requests? Right? Do I block deletion? I mean, what do we expect is the management of the Kubernetes resources in the case of ad hoc deletion of different parts of it? And then yes, of course, we can set a flag in the bucket that says, delete only the Kubernetes stuff, don't delete the back stuff. And that would be the default for brownfield. But so it's really more the case of greenfield with multiple references, so that my behavior is delete, not retain, and I've got multiple references to it. Which of those references causes me to be deleted? And if I am deleted, what do I do about all the other people that are referencing me? How do I invalidate those references?
Shouldn't we use the patterns from PVPVC to mimic how we handle this? Because today I can have storage I've dynamically provisioned. I can have multiple applications in my same namespace having a claim to that, and I can change that I want to delete or retain. Why?
But you can't.
How is it done there?
In fact, the way that's solved is exactly the way I suggested that this might have to be solved, which is that's a doubly bound thing. It's a one-to-one between PVC and PV, right? If you have the one-to-one, then that model, I think, completely works. The problem is when you get many-to-one. And I'm suggesting maybe we don't do a strict many-to-one where we lose the many. We literally just keep the list of all of the references at the bucket level. And then we have effectively a double binding. We have multiple two-way bindings rather than ref count or I don't know who's referencing me or something like that. That's all.
Right.
And then
What is the problem? What is the problem for the controller to just query and see? I mean, it's not. Is there a concern about information loss here, or
I'm worried about race conditions and and the various problems around
But you have less race conditions when you have information once, right? So in this case, it's easier to, and you're worried about the deletion point, right? Deciding to delete something. I think it's probably solvable in in one or two ways, though, just to make sure that something will not accidentally delete.
Yeah, that's where the binding comes in.
I'm just suggesting that I think dragons be here, but sure, I think somebody could
It
come up
might
with
be.
No, I like what Andrew's suggesting. I think that's going to make life so much easier. I am still wondering about the whole delete automatically kind of feature where you create a bucket, and if retention policy is set to delete, it just gets cleaned up on its own. How about we make deletion we never delete by default, and deletion could be a whole other operation like bucket deletion request. We'd still need the bindings.
I think it's a very simple usability for, I don't think it's really, it might be difficult actually for drivers to sometimes implement it, of course. But so maybe that is a good case for separating it somehow. Right? Because cleaning all the data synchronously might be complex in one ways. Of course, if you do implement it, it's a very good feature for automation.
Depending on how much data is in the bucket, it could take weeks to delete.
So I think if you use it for, I think it mostly makes sense when you automate, like if you run a CI task or whatever, like anything automated, triggered from somewhere, which allocates a bucket, does some, work, even maybe spans out more applications to share that bucket in some way or another, and then shuts it down. And you want everything to be cleared up. You don't want to leave anything. Anyway, you can always have specific cleanups in your CI.
As I think about it, I think it might be a bad idea. Just help me think this through. So if I can't think of any other Kubernetes resource that has this deletion request kind of concept. And the reason I think is because if you have this concept, you're essentially making it imperative, because you can only delete after it's created. Yeah, probably a bad idea to have this.
Yeah, it's less of a declarative model to delete,
right.
Have a delete request.
Yeah. The original reason I thought of this was because if deletion wasn't a part of creation, or it wasn't a retention policy thing, and if deletion was always manually invoked in some way, basically by creating a bucket deletion request, maybe we didn't need the bindings is what I thought. Because I don't know how I went there, but yes, but it doesn't make sense. So
So what is the consensus on this then? Are we considering a deletion API, or are we
no
going to move forward with it?
So what Andrew was saying, I think that's the best approach, at least so far. We have a binding for every bucket request to a workload. So each time a new workload needs a bucket, they make a separate bucket request, and we know exactly what the bindings are, even if they're pointing to the same bucket. So you can have multiple bucket request bindings for the same bucket in a given namespace, and clean up would know how to clean up because we have all of this listed out.
Yeah, just to be clear, I wasn't trying to necessarily strongly propose that model. I was just saying, I have been uncomfortable with the fan out of multiple requests pointing to the same bucket, because I just haven't seen it all fleshed out what the lifecycle management looks like. That's all I was pointing out, is that I think it'd be worth going through all the lifecycle management cases and figuring out how provisioning and deprovisioning works, and when you're going to be doing final, when you're going to block deletion, when you're going to under what conditions what, and then it might be that I cried wolf and that this is going to be fine, but I'm just a little uncomfortable until I see that, I think.
Fair enough.
So, not trying to propose a particular solution, just pointing out that I feel like we've papered this over a bit and just assumed that it would be okay. And if it isn't okay, that's a pretty fundamental change to the architecture.
Yeah, definitely. I know that we had considered early on keeping a list of references on the bucket, but as Guy pointed out, we had some concerns about the reliability of that list and how easy it would be to keep that actually up to date. But I don't think that's a reason not to explore it as a solution.
So the reliability of keeping it up, what does that mean?
Keeping the actual list of references up to date with the actual bucket requests in the cluster that do reference that bucket. Or to put it the way I think Guy put it, you're now using two separate models, right? Where you have a list of references in the bucket, but then you also have to query all the bucket requests and see who references the bucket. Is that what you were saying, Guy? Or am I off track here?
Yes. No, it's just the same information from a different angle. But I do agree with Andrew. I think we should go over it. Maybe next meeting we should go over how the bucket request cardinality and sharing works and the use cases, so that we see like which tweaks we need to the API. For example, like deleting data versus not deleting data, etc. Right?
Yeah, agreed.
Hey, I had a question that's slightly orthogonal. I've been implementing the make bucket API, and a whole bunch of times with the different cloud providers, one of the requirements that comes up is a project ID or owner ID that's required. I'm not sure we accounted for this in the existing API spec. If say I'm using Google Cloud, I'm running a Kubernetes cluster in there, and I want to use the storage buckets for the same cluster, the Kubernetes cluster. I could have multiple projects using multiple Google Cloud projects using buckets. So would that be a field that's passed in by the workload in the bucket request, or would that be a field that's per provisioner? So you pass it as a flag to the provisioner. That's something that I'm thinking about.
So the way that we handle it on the CSI side is we require the driver, when they give us a unique ID, to be effectively complete. In this case, it's a fully qualified ID that's returned by, for example, Google Cloud. So when they give you a volume ID, instead of it just being the name of a persistent disk, for example, it'll be a fully qualified name, including the project and zone. And so when Kubernetes returns that to the CSI driver at a later point to operate on it, the CSI driver can then have all the information that it needs.
Is there a security concern or access concern in identifying which namespace is allowed to provision resources in which product?
What do you mean?
So the case I'm thinking of here is if we have a driver that supports multiple projects. Well, I guess that's the premise. Let me ask, is that correct?
Mm-hmm,
Generally
not. Okay. So yeah. All right. So if
wait, sorry, did Andrew say no?
Right. Yeah. The clusters live in a project, right? So
they don't provision resources outside of the project.
I mean, they could, but that would mean they would need a mechanism. Either they would have to have permission to another project, in which case it's just IAM again, right? And so you just do things with full references to include project ID and everything. But generally, clusters are project scoped resources themselves, as are disks. So none of these things span clusters. And so the only way to span a cluster is to explicitly do operations span project. The only way to do that is explicitly have a full path to something in another project. And then you just have to have the IAM permissions to do it.
I think there is a difference between PDs and buckets. I think it's not possible for GK cluster inside a project to see PDs from other projects. But at the same time, there is nothing that prevents you to see buckets from other projects. So I
Sure.
think it's a little bit different here.
Right. Yeah.
So the question I have, and maybe it's a moot point, but say there are brownfield or potentially I want to provision greenfield buckets in a different project from a namespace. How do I have users that want to do that in my cluster? Should we have a mechanism for controlling, namespace access to X, Y, and Z projects?
I think it might be just an opaque parameter on the bucket class, just an idea.
Yeah.
Oh, you mean they pass it in the request? Okay.
No, so you would have to. So the problem here is, I think everybody understands the provisioner is going to have a set of permissions.
Right.
The question here is, how do you want to limit the use of that provisioner by other users? And do you want us to somehow, if that provisioner could potentially have access to resources in another project, but you want to keep this user from having access in another project, I think the only way that you can do that is with bucket parameters in the bucket class, and not put that kind of thing in the bucket request. But we're sort of not allowing for explicitly asking for names and stuff like that anyway. So I think that kind of thing should already have been handled through bucket class, right? References to other projects or anything else.
Yeah. No, that's true. Okay.
Okay, sorry. Did you say that we don't allow explicitly requesting a particular bucket?
Not through the bucket class.
Okay.
So
yeah, that makes sense. Yeah.
To rephrase it, like the bucket cluster scoped object would have to have been written and have to exist, and then that's how I would get access to a brownfield bucket.
Got it.
And we've talked about allow and deny lists, specifying namespaces in the cluster, in that cluster scoped object, as a way of kind of controlling access in that way.
So we're really talking about a mechanism to provision or allow certain people to provision buckets outside of the general, like the default credentials that the provisioner has. Is that right?
No, I don't think. Hopefully, we weren't talking about that. I assumed it was the provisioner has broader access than you necessarily want for particular users to have, and the solution to that was that's you manage that in the cluster scoped objects. Basically, you that's how you control what individual namespaces can get to, is you craft a bucket or you craft a bucket class that, and you say you have access to this bucket class or you have access to this bucket, which actually is an interesting point. Having access to the bucket is easy. Having access to the bucket class, I've wondered this before about storage classes, whether there should be namespace scoped access to classes. Because it's true, if you create a class that allows for dynamically provisioning buckets in another project, say, what's to keep somebody in any arbitrary namespace from accessing that class?
Right. Yeah, you get kind of a thin layer of security with RBAC in that they can't list storage classes that you would have to then specify by name, but that doesn't have any influence on the actual automation. So that
we call it security through obscurity.
For a bucket class, I think John had proposed a whitelist of namespaces, right?
Yeah, I had been thinking about doing that on the bucket object, the cluster scoped, but we could do that for the bucket class as well, because there's 2 points of entry here at that point, right? Like bucket class is strictly greenfield, and a bucket cluster scoped object wouldn't exist. The inverse is true for brownfield, where the bucket class isn't considered. The bucket would already exist and contain anything that was already in the bucket class. So
maybe I missed, but what is isn't it so for PVs it's with quota or something, right? Or
yeah, but
it's
we
not,
don't have.
it's not through RBAC.
No,
Yeah,
yeah,
PVs is through quota.
yeah, but we don't have we can't leverage quota, at least like a natively supported quota. We'd have to kind of write our own.
Yeah, I think it would be useful to probably think about having a whitelist on the bucket class object, and maybe if by default it's open to everyone or something.
And then maybe we can get into storage class too. Sorry.
Yeah.
I would not be against that.
Okay. Okay, cool. We will we'll definitely have to consider that for the API. In the last single minute here, actually Sada had a question for you regarding the new repos. This process turned out to be a little more complicated than I anticipated. Looks like now if we want either a new or a migrated repo, we have to have a sub project in the SIG. According to the SIG storage's charter,
Okay.
that requires a KEP, and then consensus among SIG leadership. So
Okay.
I looked for examples of this. I didn't see any KEPs, but obviously SIG storage has.
So the last sub project that was created was the data protection work group, and I don't know if they needed a KEP in order to get it created, but whatever is needed, let me know. If you can use your existing KEP and say, hey, here's the KEP, and we're going to create a sub project for Cozy, go for it. I'm all going to support you all the way.
Okay.
Is this just for a sub project under storage, or is this a working group? Because the data protection, that's a separate working group, so you need to have this KEP. But if it's just a sub project, I think it doesn't need that much reviews, I believe, because we have many sub projects, right? Sad.
Well, the governance docs that I've been reading, I think maybe flip the nomenclature and put sub projects at a higher kind of point of importance. And they explicitly say working groups don't own code and don't own like documentation or anything, which made me think that we have to have a sub project because we're trying to get at least some example.
Yeah, the sub project, the code is basically controlled by SIG storage. So
okay.
Yeah, so it's like, yeah, it is controlled by a sub project, but then sub project is under SIG storage. So it's not like you're not like a separate entity. I think one group meaning that you would have really it's cross SIG. I'm not against that. I'm just saying I don't know exactly what you are trying to propose, but there are like examples of sub projects already. But if you want a working group, then I think that is a little bit more. But you can ask me offline if you want to.
Shane,
group. I actually need to drop off another meeting.
Yeah, Shane, this is Srini. I'll ping you back after this meeting so we can talk about this. I want to drive this. Yeah,
okay.
Thanks.
All right. Thank you.
Okay.
Thanks, everyone.
Yep. Great. Thank you, guys.
See you.